All right. Well, the videos I posted this morning initially on Google Classroom were going over problems that were different than the practice test. Somehow, what got downloaded, the problems didn't match up. They were close. Some of them were the same, but they didn't match up. So I'm going to do this again. If you watched before 9 a.m., then those videos you watched may not have worked too well. Hopefully, this matches directly up with your problem in your practice test. Like, look, here's the practice test problem right here. It's a drag and drop problem. Here's the problem over here, what's like a fill in the blank. So on the test, there aren't going to be options over here. You're just going to fill in the blank. So hopefully that all makes sense. Let's go over how do you figure out what the interior angle is for a regular pentagon, right? So it's a regular pentagon. So I'm going to show you two different ways. The formula is n minus 2 times 180. And so if you had a five-sided figure, let me put 5 right out here. You plug 5 in where the n is. So I go 5 minus 2 times 180. That gives you 3 times 180. That gives you 540 degrees. But they want, they want one interior angle, not the sum of all of them. So what I need to do then is I go 5 into 540. And that goes in there, let's see, 1, no times 8. So it's 108 for a pentagon, right? Now, what I'm going to do is for the hexagon, I'm going to show you a slightly different way. Now, if you remember the experiment we did, it just goes up by 180 each time. So you could add 180 to this. And I think that comes out to be 720, right? And then you take 720 divided by 6. I know you're interested in probably a quick way of doing it, but let me show you one way to get the exterior angle. So a 6-sided figure. Now I'm going to do an exterior angle, and that's going to review this next problem here for you down here. So if we have the sum of any polygon, the sum of the exterior angles is 360. So I could go 360, and I could divide that by 6, and that's going to go into their 60 times. So each exterior angle would be 60 degrees. So let me draw a few sides, and then let me extend out one of the sides and see this is 60 degrees right here. So the interior angle right inside is 120 degrees, right? So let me just see if I can make this clear. I'm not drawing the whole hexagon. I'm just drawing one little corner of the hexagon so I could study that idea. So that means the hexagon is the 120 degree angle. And then the octagon, I'm going to try that the same way I did that one down there. So I'm going to take 360, that's the exterior angles. I'm going to divide it by 8. 8's going to go into there 45 times. And so the octagon's cruising along like this. And one of the exterior angles is 45 degrees. So the interior angle is 135 degrees. So that's how we answer number 1. Number 2 is doing kind of what we did up there, right? So if I took 360, I do the exterior angle first, and I divide it by 20. 20 is going to go into there 18 times. So the exterior angle is 18, and then the interior angle has to add up to be 180. They're supplementary with each other, the interior and the exterior, right? See, they add up to be 180. So that has to be 162. All right. Let's go to the parallelogram. Let's draw a parallelogram. And I was mentioning in class that you just start at one of the angles and you call it W. Then you go to the next consecutive angle. You don't go diagonally, you go consecutively. So we're going to go X, Y, and Z down here. And then we're going to put 47 in where W is. Now look, I drew it as an obtuse angle. I'm going to try to not let that bother me, because otherwise I have to erase them all and put the W, like start over here, go W, X, Y, Z. If that makes you feel more comfortable, do that. But I'm just going to stick with this drawing. So I've got 47 here, and they want to know what Z is. They're supplementary. So this has to be 133, I think. Wouldn't that add up to be 180? So 133 right there. In parallelogram EFGH, here we go again. We're going to draw another little parallelogram, and we're going to put EFGH down. EFGH. Oh, that's right there. What am I doing? Dumb. Okay, let me get rid of that. And let's go and just use this one down here. They want us to find angle G. Okay, well, these two angles right here are supplementary. So if I go 3x minus 15 plus 7x minus 5, and I set equal to 180, and then I've got, 10 x's, and I've got 20, so minus 20 equals 180. I move the 20 to the other side by adding. I get 10x equals 200. And then I divide both sides by 10. X comes out to be 20. So did they want X? It says, no, they want G, how big G is. So I take my 20 and I put it right there. So 7 times 20 minus 5. Let's see, that's 140 minus 5 is 135. So G should be 135. And then to find E, let me move the drawing up. To find EF is right there. I'm going to set 3y equal to y plus 8 because opposite sides are equal, right? In a parallelogram, I subtract y, I get 2y equals 8. I divide by 2, I get 4. And then they want to know how big EF is, so we put the 4 right back in there. So 3 times 4 is 12. All right. Hey, there are the first 4 problems. Watch the next video to get some more help. All right. Thank you.